Okay, so hi everyone, Senan this side, and in this video we are going to see how do we solve this topological sort. In the previous video I have solved this exact question using the BFS algorithm. You should check that before watching this video, but I would try to make this video without referencing the previous video. So given an adjacency list of a directed acyclic graph, you need to find a valid topological sorting of the graph. So in a topological sort, every directed edge u to v, u must come before v in the ordering. And if you see, a valid ordering for this is 3, 2, 1 and 0. In this is 5, 4, 2, 1, 3, 0 as explained in the last video. But what are we going to use in this video? So this video would be about the Kahn's algorithm. It uses breadth first search for doing this calculation or computation. So the logic is what? First of all, let's discuss what is an integrity of a node. So an integrity of a node is the number of edges that are incoming to it. So 0 has 2 edges incoming to it, so integrity is 2. For 4 its integrity is 0. For node 1 it's the integrity is 1. For node 3 the integrity is 2. For 2 integrity of 2 is 1. 5 integrity of 5 is 0. So in what condition do you think which nodes can be at the start of the answer so that they don't affect the ordering? If you think about this for a moment, the answer would be the nodes which have the integrity as 0 can be appended to the list because these are the nodes which are independent of any constraints. So given this integrity as 4, I don't have any node such that I say that I want that node occur before 4. Same for 5. I don't have any node which says, or an edge like that which says that I want node x, let's say, should occur before 5. So that is not the case for the nodes with integrity 0. So that is the logic we are going to use. First we'll store the integrity of every element and then find all the elements which have the integrity as 0. I'll take that and append it to my answer list, and I would remove these elements from the graph itself, the nodes which have integrity 0. So if I remove 4 from this graph, the integrity of 0 and 1 would decrease by 1, both of them. If I remove 5, the integrity of 0 and 2 would decrease by 1, both of them. So now I would have a new graph like 0, 2, 3 and 1. Now I would do the same thing again. Find all the elements which have integrity as 0, take that as a part of my answer and search on the remaining graph. So that is the logic we are going to use, and first of all we initialize the answer array and then we basically calculate the integrity for every element. How do we do that? We go to all the nodes and say if there is an edge between 4 to 0, I increment the integrity of 0. If there is an edge from 4 to 1, I increment the integrity of 1. That is what I'm trying. Now since we are using a breadth first search approach, we need a queue, and in that queue I would push all the elements which have an integrity 0. In this case 4 and 5. Now what I would do is take out the topmost element. I would take that as a part of my answer, and then what I would do, I would decrease the since now I'm trying to remove that node from the graph, what I would do is I would decrease the integrity of the neighbor nodes. For this 4, I would decrease the value of 0 by 1 and 1 by 1. And if at some point for this case I reach a point where the integrity of that element becomes 0, that means now that 0 is now independent of any more constraints. So I can take that as a part of my answer. So I push that into my queue, and I do this till the time queue is not empty. Now in the end I return the answer, but what is this check doing? So this check is basically saying that if answers dot size is not equal to v, return empty list. That means that we were not able to reduce the integrity of all the elements to 0. So that is only possible when you would have a cycle in your graph. And since there is a cyclic dependency, the integrity would be always greater than 0. So we would never reach a condition of this, right? Integrity being 0. So the answer dot size is not v. That clearly states that the graph has a cycle in it, and in that case I just return an empty list. Otherwise I return whatever the answer that I had generated till now. So that was the video all about. Hope you understood it, and the time complexity, space complexity would be same as the breadth first search, which is big O of v plus e for the time complexity and big O of v as the space complexity. In this case we are not using the visited array, but we are using the integrity to keep track of the visitedness of a node. So that is why this is a modified approach towards the breadth first search. So yeah, I'll see you in the next video. Bye.